The first part of the logistic regression program was to import many files. The first file imported is NumPy, as it is the basic library needed for scientific computing in Python. NumPy provides for manipulation of numerical data. To add on, it provides us with valuable objects like arrays, where we can perform specific operations and also rearrange into matrices. Pandas is another important library, which is used to work with tabular data or data in table forms. For example, a programmer can create data, add and remove rows from tables, and rearrange the data. Matplotlib allows for the use of graphical analysis. Nevertheless, one can generate plots, histograms, bar charts, scatter plots, and much more. Seaborn is a library that adds additions to Matplotlib, as the diagrams made can be more attractive and informative when doing graphical analysis. Logistic regression was downloaded to allow for the basic construct of the classifier. Other parameters could also be adjusted to fit the data more accurately. The train test split function randomly splits the data into a training and testing dataset, which will be emphasized on later. Importing the accuracy score and metrics allows for users to see how accurate the program actually is. It does this by comparing the answer predicted to the actual y value. Moreover, importing PyPlot can change a figure created by Matplotlib by creating a plotting area for the figure, plotting new points, and adding labels. GridSearch-CV was the last library downloaded, as it allows to fit the logistic regression model better by adding even more parameters. From here, the data table was actually added to the program. The data table was called cardiovascular. The head function allowed for a user to see the first 5 rows in the dataset. Further, using the cardiovascular drop function, we removed the columns that we did not want. As explained before, these features were unwanted as it would make the model overfit and cause a decrease in accuracy. The cardiovascular head was once again run to cross-validate the above. One can see this in the data on the screen, which only represents the wanted features. The n iterations was further set to 1000, which will be important later on. Not just this, but the x values were set to the input values for the cardiovascular dataset, and the y values were the output. Remember that the input values were the different features like blood pressure and glucose. The output value is if the patient had cardiovascular disease or not. The variable stats was then named to list, which will be important to analyze results later on. A variable called paramGrid was also added to change the C value. Now, this C is one of the major parameters in logistic regression program as it helps with accuracy. More specifically, C is the inverse value of the variable lambda, which retains the strength of the model. The variable scores then let users compare the prediction variable to recall to show how accurate the model actually is. Next, the training and testing dataset was split to 70% and 30% respectively, the ideal split for logistic regression. The training dataset must always be larger, as it can track better relationships, as more data leads to more validation. The increased amount of validation from the training dataset will further increase the accuracy in the testing dataset, as the logistic regression model will be more confident with its prediction. Now, the GridSearch-CV was used to create the basis of the logistic regression model. However, an L2 regularizer and different C values were added to optimize this program. Nevertheless, a L2 regularizer was added to counter overfitting, once again increasing the accuracy. This model represented was then also applied to the testing dataset. Furthermore, the logistic regression model was run on the X-test model, and the Y values predicted were called Y-pred. Then, the accuracy between the Y value and the actual Y output was found and was named score. Further, the best C values were also found. You can actually see how these C values and accuracy contrast in between two of the iterations. The best C value with the highest accuracy for these two values was 0.1. You can see how the accuracy of one differed from the other, as the first one was about 83.95% and the second one was 84.14%. Using PyPlot, a histogram was formed to see the difference in accuracy or score. Confidence intervals were also made in order to show how confident a model was in its specific accuracy. In this histogram, one can see that the highest accuracy is about 87%, but the confidence is pretty low. The greatest confidence is actually at 85% accuracy, as 290 out of the 1,000 trials were close to this value. However, the model is 95% confident between the 83 and 86.7% accuracy margin. In the next video, I will be talking about how I made my neural network. I hope to see you soon.